Hi, how are we all doing? Right, today in this video I'm going to talk to you about these three identities here. So this one you've met already, probably in year 12, sine squared theta plus cos squared theta equals 1. But in year 13, when you're introduced to sec, cosec and cot, there's two more identities that come with it. Okay? You need to be able to know how to derive those as well from the first one. And it's actually rather simple. So if I start with the top one, so sine squared theta plus cos squared theta is equal to 1. If you divide both sides by cosine squared theta, to write this over cos squared theta, this over cos squared theta, and then this over cos squared theta, can you see you end up with this one here? Sine squared over cos squared is tan squared. Cos squared over cos squared is 1, and 1 over cos squared theta is sec squared theta. Okay, so it's a rather simple step. You start with this, and then just put in this line, and then you've got your result. And for the last one, you do the same sort of thing. I'm going to start with the top identity, and then divide both sides by sine squared theta. So divide that by sine squared theta, divide that by sine squared theta, and this, dividing everything throughout by sine squared theta. And then this is just 1. This over this, cos over sine is cot, so cos squared over sine squared is cot squared theta, and then 1 over sine squared theta is cosec squared theta. Just going to move away in case you want to take a screenshot of that. So what I recommend is you certainly should have that one memorised by now, but then know how to use that to derive the others, because frequently you need to apply one of these to a question, a scenario, and you might not remember it fully. Is it tan squared plus 1 or is it sec squared plus 1, for example? Just starting with this and knowing what to do to derive each of these can help you to derive those from scratch should you need an exam. So that's those. I'm just going to take you through some examples in solving equations now. So back to these ones, okay? So you need to know how to solve simple case scenarios like sec theta is 5 and cot squared theta equals 3. Okay? So this, the first thing you do is realise that sec is the same as 1 over cosine, the reciprocal of cosine. But what I tend to do is I tend to rewrite it as this. Cosine theta is 1 over 5. Okay? This is the same as this. Because your calculator, here it is, okay? It's got the sine, cosine, tan buttons, hasn't it? Okay? They don't have cot, cosec, sec buttons, wouldn't that be nice? No. So in order to solve an equation, you need to have cos theta equals something, sine theta equals something, or tan theta equals something. So this just rewrite as cos theta equals 1 over 5, and then just do the inverse cosine of 1/5. And just to save some time, I've got the answers up there ready. You can check them if you wish. So 1.37, 4.91 within this given interval. It's in radians, of course. Right, with this one, cot squared theta, you can do a similar thing. So you've got tan squared theta here is equal to 1 over 3. Okay? And then you take the square root of both sides. But be careful when you do that. When you take the square root of both sides, you're going to get tan theta is positive or negative 1 over root 3. Okay, positive or negative 1 over root 3. And that means you're going to get 4 possible answers, of course. So we'll do the inverse tan of 1 over root 3. Okay? And that gives you 5 over 6, 7 pi over 6. Then you do the inverse tan of negative 1 over. Now, if you're in a calculator, you do that. So I'm going to type in 1 over negative root 3. Yeah. So if you do the inverse tan of negative 1 over root 3, the first answer it gives you is negative pi over 6. I don't know if you can see that. Okay. And so what you need to do is think, oh, it's not in the interval I need, so you just got to add pi to that. So when you add pi to that, you get your first answer, 5 pi over 6. Okay. In case you're wondering where to get the first answer, then the next answer you add on pi. I've got another video somewhere of the basics of generating multiple solutions. Okay, that's not this video, so I'm just going to rush through the answers. This video is about how to use equations involving sec, cosec, cot, and the identities. This one here, recognise that as a quadratic form. I've got another video, okay, probably aimed for year 12, but it's in my trigonometry playlist. Okay, I've got another video showing you how to solve quadratics. Okay, and you need to recognise that this is a quadratic equation. It's a nice and easy one because it's all the same trigonometric function, cosec. So what you should do is factorise it using cosec theta. So 2 pairs of brackets because you've got the 3-term quadratic. So 2 cosec theta, and this will be cosec theta, okay, equals 0. Don't forget the equals 0, it's an important part of this because it's an equation. And you have 1 and 2, so it will be 2 there and 1 there. And this needs to be positive 3 cosec, so that's going to be plus 4 cosec minus cosec to give you the 3. So that's that. And then, of course, that gives you 2 cosec theta is equal to 1 over 2, or you've got cosec theta is equal to negative 2. And then you just write it in terms of sine. So this one here will be sine theta is the reciprocal of that, so negative 1/2. And then this one will be sine theta is equal to, sorry, I've got no idea why I wrote 2 there. I apologise profusely. Some of you are probably thinking, no, what's he done? Yeah. So I've got cosec theta is 1/2. Yeah. So sine theta and reciprocal of that is 2. That will have no solution, of course. So don't try it in your calculator. It'll got math error because there's no solution. You can't do the inverse sine of 2. Okay? So that's got no solution. I sometimes write down there, no solution, just to show that there's no answers generated from that part of it. So it's just this then, inverse sine of negative 1/2. Okay? And there's your 2 answers there. So the first answer you'll get when you do the inverse sine of negative 1/2 in your calculator will be negative pi over 6. And then you subtract that from pi. Pi subtract negative pi over 6 is 7 pi over 6. And then your other answer generated is 11 pi over 6. So that's some simple equations to begin with. And I've got one more for you, which is this one here. Now this is going to make use of one of those identities that I mentioned. So remember what I said about recognising when it's a quadratic? So you've got a square term, you've got a number and a non-square term. Your typical trigonometric quadratic scenario. What to do? You've got to replace one of those so that you've got the same trigonometric function. Now, because the identities that I've looked at are these ones here, you can replace one of the squared ones, okay? And I hope it's obvious it's this one here. Tan squared theta plus 1 is sec squared theta. But if you're in the exam and you've got difficulty in memorising the identity, just go back to this, what I said earlier. Okay, always go back to this one if you're having trouble remembering what identity involving tan squared is. So start off with that. To get tan, you need to do sine over cosine. So divide both sides by cosine. Okay, cosine squared that is. Don't need the plus there. So divide that by cosine squared and divide that by cosine squared, and then you'll have it, you see. So that's the tan squared term. That's the 1, and then that's going to be sec squared. So that's your identity, see? And then you just put it in here. So 2, and instead of tan squared theta, you just want to put the 1 onto that side. So you'd have sec squared theta minus 1. So that's the tan squared theta bit, sec squared theta minus 1. And then plus 11 equals 9 sec theta. And then you just expand the brackets and simplify. So 2 sec squared theta, that's going to be minus 2. And then plus 11 is equal to 9 sec theta. Put all the terms onto one side, make it a quadratic equals 0. So put this over there, so minus 9 sec theta. And then that will be plus 9 equals 0. And then go ahead and factorise that. If you were to factorise, 81 minus 4ac, so 81 minus 8 times, yeah, that will factorise. So I'll just check with the discriminant. That's my normal go-to to see if it will factorise or not. So 2 sec theta, and then sec theta equals 0. I'm going to want 3 there and 3 there, and plus 9 negative, so that's going to be negative, negative. All right, so just check that. Negative 6 sec theta, subtract 3 sec theta is negative 9 sec theta, and then plus 9. Great. So then we've got sec theta equals either 3 over 2, get it right this time, 3 over 2, or you've got sec theta equals 3. Okay. Scroll down a little bit, just remember it's the interval between 0 and 2 pi. So this one, you'll have cosine theta. The reciprocal of that will be 2/3. We can do that. We can work out answers. Let's do it now, shall we? So inverse cosine of 2/3, calculator radians mode, inverse cosine 2/3. 0.841 is the first answer, and then subtract that from 2 pi, subtract that, 5.44. And then you've got this one, so cosine theta is equal to, reciprocal of that is 1/3, and then theta is inverse cosine of 1/3. So inverse cosine 1/3, 1.23, isn't it nice? 123. 1.23 equals 2 pi minus that one, 5.05. And we're done. Okay, and that's it. I'll just move out of the way in case you want to do a screenshot of that. Okay, right. Hope you enjoyed that. There's some more trigonometry videos coming your way.